Hey everybody, this is Gregory from Dapp University. So today I have another guest on the channel. I've got Austin Griffith here, who is a previous guest on Dapp University. So I'm glad to have Austin back. And he's going to demonstrate a topic for us today. He's going to do a little screen share to kind of show some new tricks that we can add to our tool belt when developing decentralized applications for Ethereum. So welcome, Austin.
Hi, how's it going? Have you had repeat customers before?
I think I've had a couple, but yeah, you
Awesome.
were definitely one of the first.
Cool.
Yeah, man. So great to have you on the channel today. So what are we talking about today, Austin?
The EC recover function in Solidity.
Okay, awesome. So you want to maybe give us a really basic explanation of what that is and why we're talking about that?
So EC stands for elliptic curve cryptography, and I'm not enough of a math nerd to be able to really explain it. There's some really cool diagrams you can see if you Google it, but the heart of the trick is it works with your public-private key pairs, and the private key pair signs any given message, and that's going to output a signature. And then given that message and that signature put together, that's going to output the public key from the public-private key pair. So you can on-chain verify that a certain account signed a certain message.
Awesome. Yeah, very cool. So that seems like that opens up a lot of doors. So what kind of things would that allow you to do?
Exactly, right? So like a lot of the off-chain stuff that you can do where you can put together like an off-chain transaction, you can sign it, and then it can be submitted by someone else, and then it can be recovered, and you can prove that it was you that signed it. So meta transactions are big. Another thing would be like state channels. You could send somebody a full state and have it signed, and then they could then submit it on chain. It could be recovered and prove that it was you that signed that state. And a lot of like off-chain stuff too. It doesn't have to be on-chain. Lots of uses for being able to tell that a specific account signed a specific thing, and that whatever they signed, like it could be a date, it could be information about something, it could be a transaction. It opens up a lot of doors, like you said.
Yeah, very cool. Awesome. Well, I'm excited to see a demonstration of this. You want to share screen and kind of get us started?
For sure. Okay, so I just created like a blank project and then installed Clevis. So if I jump over to my GitHub, which is Austin T. Griffith, there's a Clevis link there, and that takes you here. And this is just kind of getting you set up with how my environment works. I just pull down Clevis and link it, so then it becomes like a binary I can use. Mm-hmm. So like I can just type it in here and kind of get the version of Clevis or whatever. So then from there, I made a directory called EC Recover, CD'd in, and just did a Clevis init. And Clevis init brings up all sorts of stuff. I wrote an article about it. I think it's right on the Clevis repo, and then did like a screen share. So that just kind of gets you ready to understand the environment I'm working in. So I'm going to go ahead and create a contract called Recover, and we'll start coding on that.
Yeah, really quickly before we jump into that. So for anyone who's watching it may not be familiar, you want to educate us on Clevis?
Yeah, so yeah, Clevis is like my blockchain orchestration software. It's kind of like Truffle. It's probably not as good as Truffle. That's what I always say. Like disclaimer: I am not a genius, but it's similar to Truffle in that you use it to compile, deploy contracts. You can also use it to interact with contracts. And then I have like Mocha over the top, so it can kind of orchestrate deploying contracts for me and stuff like that.
Very cool.
So let's create our recover contract. So the first thing I'm going to do is bring in OpenZeppelin. And like one of those things, you should never do it yourself if someone else has already done it for you better, right? So Zeppelin Solidity has a really cool, so this is their signature bouncer, but their, EC Recovery is what I'm looking at. So EC Recovery does the actual, let's see, where is it? There's the EC Recover right there. So what it has to do is split up into different parts of the signature and then call this function with the hash. It'd be the hash of the signed message. And then the different parts. And there's also this thing that it adds on. I don't even understand why that's there, but I guess a lot smarter people know why that's there. But for some reason, whenever you sign a message like in MetaMask, it appends this Ethereum signed message And that would really throw you off if you didn't know that that was there. But thanks to Zeppelin, we can just use their library. And if you need an example of how to use it, you can jump over to the signature bouncer, which uses it all over here. But this is kind of the key right here. So we're getting the address by taking some hash. So first we have to say something like use EC recover for bytes 32. And once we're using EC recover for bytes 32, then we can take this bytes 32 that comes in, do a to ETH sign message, which adds that string to it, and then do a recover, which we pass the signature into, and then what comes out of that is the signer. So you can kind of go like reverse some kind of sign thing to get the public address from it, and that will be really powerful. We can talk about why in a second.
Sure.
So let me bring in the EC recover like it was, and we'll set up, what we'll do is we'll make a super, super simple contract, and we'll set up just an event that fires a message. So it'll just take in some kind of address and then some kind of string. And then let's just go ahead in our constructor and emit a message that says like the address of the contract deployed, right? And we'll just kind of follow those events through, and it'll help us debug. Cool. So here is the whole heart of the contract right here. Basically a message function that will take in a string and some bytes. So a signature isn't a bytes 32, it's actually a byte array. Like it's bigger than a bytes 32. And what we'll do is we'll take our message, and you don't really need this encode packed unless you have multiple things. And we'll probably get to that. We'll see how long this takes and if my kid starts crying upstairs. But what we do is we'll hash our message together, and that will create a bytes 32 hash. And we'll also hash our message off chain, and we'll sign it there too. And then the signature will come in as this second argument, and that will be passed into that recovery stuff that I was talking about earlier. And then finally, we'll emit a message from that signer that that this signer sent this message. So it kind of like all we're doing here is kind of just like sending events saying that certain people signed certain messages, right? And with Clevis, we can kind of get that compiled. See if that goes through. Uh-oh, what'd I do wrong? Oh, dependencies. Okay, so we also have to bring in Zeppelin dependencies. I think I have those laying around here too. There we go. So I'm just saying I'm importing these. So with Clevis, you have like an arguments, and that's what's passed into the constructor. You have a dependencies, which is it kind of prepackages stuff for you for the final compiling. And then you have your normal contract. So now cool. Let's see if this works. Demo. Brrr. Any questions yet?
No, I think I'm
awesome.
Following along just fine.
Okay, so there we go. So it spit out the contract. It's got it compiled. Let's go ahead. So I think I have, yes. So I have Ganache CLI running here. That's kind of an important thing. Here, I can kill it and start it back up again. Oh, maybe I can't. Oh, there I did. Okay, so and Ganache CLI it's sort of like the command line behind Ganache. Ganache is like it's like a very nice UI. It's basically a blockchain, a local blockchain ready to go for you. It fills up a bunch of accounts. I use the CLI because with my game Gallias, I would compile and deploy like a whole bunch of contracts. And for some reason, the UI wasn't working. It probably works by now, but now I'm just in the habit of using Ganache CLI. So there's our blockchain. It's up and running.
Yeah, I started doing more CLI-based work, A, because I just prefer CLI tools, but B, I was writing projects where we had a lot of unit tests that consumed a lot of Ether, and so I needed to restart Ganache every time that the entire test suite would drain the Ether from accounts.
Yep, exactly.
The command line.
Okay, so I've run, so we've already compiled, then I ran deploy, and that 0 at the end just says like use account index 0. And then I ran a test MetaMask, which is just gonna feed, it's kind of like a test I have prepared that feeds my MetaMask accounts with a little bit of fake Ether on my local account. And I don't know if I ran that. Let's make sure I ran that. I don't think I did. Okay, so now those accounts should have some Ether, and then Clevis test publish is going to push. This is a really cool thing about how Clevis has Create React App built in. So when you do a Clevis init, it's going to set up not just like your contracts and your blockchain stuff, but it's also going to set up a React app. And that comes in here. It also does stuff like carve out the service worker and a few other things that I've found that are just really helpful. It also brings in Dapparatus right there. So cool. That is going to be a bunch of like, now we're going to move over. I'm going to assume that the thing is deployed and good to go. We're going to move over to the front end and start interacting with it. So the next thing I'm going to do would be a Clevis start, and it looks like our web server is already up. So I should be able to go here and jump over to our testnet. Oh, shoot. Actually, I'm in the wrong folder. Here we go. We got to go to the D app. EC recover dash Dapp University. Okay, this is going to work. So this just does basically an npm start, but I kind of I wrap a lot of commands with Clevis to just make things easier for me to remember.
Yeah.
There we go. Okay, so awesome. So this is kind of like a shell Clevis Create React app, and boy, do I need a designer to help me out with it. But this is what I got so far. So it's basically, this is—
if anyone's watching that wants to contribute.
Exactly. So it brings in, so out of these components, these are like these pre-built components that I found. Let me just jump to my, let's see, here is my GitHub. If you go to Dapparatus right here, it's going to have all these different components that I've done like numerous hackathons now and tons of little projects that I build out, and I find that I use these same components over and over again. And the number one component is this MetaMask component, and that gives you this right here. And so if I were to jump to like Ropsten or something like that, I've got it hard-coded to tell me that I only want Rinkeby. Where is that? Right here. Here's the MetaMask component. So I'm saying I only want Rinkeby or unknown, which would be our local network. So it kind of just warns you if you're like on the main network and you're not supposed to be, or vice versa, right? Like if you're on a test network. And so let's jump to our, there we go. So now we're back on our normal network. Down here in the bottom right is our block loader and our transaction loader. So that is a different component that is right here. And that comes in and it follows along with the block logs, or the blocks as they're mined, and makes sure that like, it kind of like tries to keep track of an average block time and lets us know like when the block gets mined. But on Ganache, we're not going to see blocks pass by because it's only going to mine a block like as we send transactions. So let's just skip on, and then transactions will show up there too. So let's start looking at our UI. So another component is a contract loader, and that's another thing with Clevis. As you do, when I ran that Clevis publish, it pushed all the contracts and all the information into this folder. So you've got your bytecode, your block number, the address, the ABI, everything that React is going to need to feed into Web3 and to be able to interact with the contracts is going to be here in this folder here. So let's see what else. So let's go to, and gas too. So there's a gas component here too. We're keeping track of what the gas is at, and as gas prices fluctuate, it should automatically pick out a gas price that's going to get your transaction through quickly.
Nice.
So now let's build a UI. So let's uncomment this and uncomment this. And our contract is called recover. So I'm just going to plug a few things in here. I think it's called recover. Let's see. It'd be, yep, it is recover. Okay. So we'll put in recover there. And all this stuff comes with the default Clevis in it. Like all this stuff will be here that you can just kind of start uncommenting things as you need them. And let's see what else we need here. Actually, I've got an even better setup. I think I've got the UI kind of put together. Well, let's just see what this gives us first. Recover, yeah, this is from my broadcaster. Okay, so let's just, okay, and these are for events. Let's not worry about events right now. I'll bring those in later. But basically, these are two more Clevis UI elements, and they're here, or Dapparatus, I'm sorry, Dapparatus UI. There's an address and a button, and it just makes it easier to have, there it is. So an address gives you this kind of display. It'll give you the public address and how much Ether they have. And then if you click on that and you're not on localhost, it'll take you to the Etherscan address and get you set up.
Nice.
And then that's just an input, but here's our button here. Okay, so let's clean up that UI a little bit with one that I've kind of built for this specific setup. And that will go here. And I'll post all of this up to GitHub so anybody can
very cool.
use it from here.
We'll be sure to include a link to that down in the description below.
There we go. So we're going to have an address that will be the contract address. Then we're going to have another address, which will be our address. Then we'll have a string input that, I'm just now remembering I need to do a handle input too. So this will be kind of my handler, and I'll get to that in a second. So then this UI should be updated. There we go. That looks a lot better. So I just put in some more inputs and some more buttons, and I'll kind of go over that now. So yeah, so you have an input here that will be your message, and that will be this string right here. And then you've got a hash, which we want to auto-generate, right? We want to, as I'm typing in the message box, I want it to auto-generate this hash, because that will be what is passed to, in the contract, the message will come in, but it will immediately be hashed. And then we'll take that hash and try to recover the signature. So what we can get from that is a whole bunch of things, not just a message, but say like with meta transactions, you're signing like the contract address and a lot of other information, like how much ETH you want to send and what functions you want to call. All of that stuff gets packed into a single SHA-3 hash.
Nice.
Okay, so then in our UI, oh, it's loading over here too. That was confusing. Okay, so I can close this guy. In our UI, yeah, so as I'm typing this, that's updating. And let's cover how that works. If I go to the app, so let's see, we're doing a handle input on the change of the message, and that was that handler I put in here. And we're saying if the target is message, go ahead and create a hash. And the hash is using the same exact function that we're using in our smart contract. So we should get the same hash. Given we put in the same message here, we should get the same hash out of it. And then what do we want to do next? We want to have a sign button. Okay, so the sign button is here. And on click, we are going to do this. We're going to call on Web3, which is injected from MetaMask, and we're going to call a sign on whatever our hash is. And let me demonstrate that. So if I have some text, let's just say, there is the hash of Hello Dapp University.
Nice.
If I sign that, so this is the hash, right, of the message. It would look a lot better if we were signing this, but in the long run, we're going to want to pack a whole bunch of things in there, so we're just going to have to sign this ugly hash. I think one day we'll figure out how to make that work a little bit better, like if you pass a thing and then it could verify that that's the hash of that, and then it like lets you reverse the message, sort of. But signing that message will then fill in this signature. And notice how this signature is a lot bigger than a bytes 32. That's our bytes array I was talking about earlier.
Yeah.
So the sign calls this sign function and gives us a sig back, and then that signature goes into the React state and then populates this field. So then finally there's this last piece, which is this last button. And this is where we're actually going to interact with our smart contract. Okay. We are going to, and this TX comes along with the transactions component in Dapparatus. So when, instead of just doing like a .send on your object, I pass it in and let this transactions component handle some stuff, and it'll give us a lot better UI, and it also gives kind of a nice, pretty like callback. See how it's like basically you put in the thing you want to call, and here's the callback you're going to get back. So that's why I like colored the buttons specifically for this to like demonstrate how nice that is, because building UI for blockchain is very difficult.
Yes.
Blocks get mined in 15 seconds or 45 seconds or 2 seconds. So here we go. We're going to say, okay, so we're going to grab the recover contract and we're going to call the dot message. I think that's what we called it, making sure that my demo is the same as, yep, we're going to call the dot message. And that takes those two, it takes in a message and a signature, and we'll get a receipt back, and it'll change our color, the color of our button back. Okay, cool. So now what's going to happen when we do that on the thing, on the contract? It's going to give us a hash. It's going to figure out who the address is of the signer, and then it's going to emit some kind of event out here, right? So lastly, we need to pull in these events and watch for them. So in our contract, or in our front end, I'm going to bring in an events module from, you can find it right here in Dapparatus. Let's see, events, right? And it'll say like what contract you want to get the event from, what the event name you're looking for. If you have like a unique ID, that would be the key of the ID. Maybe you want to filter. So you can bring that component in, and it's just going to start following events for us. And I will bring that in. Actually, I'll put it right here with our UI. There we go. So there's also this hide equals true. I'll set that to false. And we should see just a little bit of display. A lot of the Dapparatus components are actually hidden because they're kind of doing stuff back. Oh, look at that. We've actually already got an event. And nice. We knew that because we were going to do a contract deployed. So that's pretty cool. So basically, this is the address of the contract. And I think we can see that that matches this right here.
So is this just the event stream?
Yes, exactly. We're seeing the event stream here. But let's clean that up a little bit and make it look a little nicer. So what we'll do is we'll create, let's see, this is in the render function of the React app, right? So in there, we'll create an array for our objects, and then we'll just kind of iterate over all of the events. So for E in events, then you're going to have, this is the event object, and we can see in the contract that the event is going to have a signer and a message. So we use those here, the signer and the message here. And then again, I'm just going to use another Dapparatus component. I'm going to say, let's bring in the address component and pass the address to it. So then we should get a nice view, just like we have for these other addresses here. We should get that same view. And it looks like I need to also display the messages here. Uh-oh, I'm getting a failure. Oh, events is not defined. What am I doing wrong here? Events should be, oh, it'd be this dot state dot events, right? Let's do this. I think that's how you do it. Let's see what it thinks about that. It does not. Oh, I'm doing it wrong. That's why I like to do some copy and pasting. So my crazy syntax is, okay, so the front end's compiling over here. Compiling. And there we go. Okay, so now we have this nice display here for, instead of getting this raw feed in JSON, we get a nice feed. So we can go ahead and turn it off. We can go ahead and just hide those contracts. And since they're hidden by default, I'm just going to delete that line.
Cool.
So we should see those disappear. And I think we're about ready to send our first message to our contract. Okay.
Nice.
I hope I'm not forgetting anything. I think this is basically what we need to make this work. Let me check the initial state. I bet we're throwing some, yes, I bet we are. I bet we're throwing, I need to bring this stuff into, just so our state is set up. Oh, you know what? We should just, real quick, that reminds me, we should look at the console. No, I'm kind of delaying the cool part, but the console, we're going to see some cool stuff. So that MetaMask component, I'm debugging it here. This is all the information that brings us out. It tells us what account we have, the average block time, the balance, like all your kind of average, interfacing with the blockchain kind of information. Contract loader, same thing. It gives us our contract back. What else do we have here? There should be gas. There we go. There's the gas object. It's telling us what we should be spending for gas right now if we want it to go through quickly. And probably events came in there somewhere too. But basically, if you're pasting these Dapparatus events in, you can kick over to the console and see what kind of data is there.
Sure.
Okay, so let's do this. So hello world. And then I'm going to sign that. And there we go. There's my signature. Okay, let's see how this demo goes. Here we go. We're going to send our hash. Actually, we're going to send our string and our signature to the blockchain, and it's going to cost us about 6 cents at, I think we're running 4 gig away, right? Let's see. Yeah, 4.7 gig away. So that's a pretty typical, 4.7 is pretty typical when it's not cloudy, right? when the weather's not bad on the blockchain.
That's right. There's no smog.
Exactly. So there we go. Actually, that came through. Oh yeah, we're on the test net. I was really surprised that came through so quick. I spent too much time out on Rinkeby and the main net, but thanks to Ganache, that comes through very, very quickly. And
it's always a surprise when you've only been using Ganache to develop something, then you push it out to a test network, and you're like, oh, this is a lot different experience.
Exactly. If you're designing UI, you almost have to like just get things sort of wired up on Ganache, and then you need to go out and like run your UI and do your UI work on a test network.
Oh yeah.
Okay, so that actually worked, right? So this is interesting. So that this address, right? I never posted my address. All I sent in to that contract was our message and our signature. And then it hashed our message and recovered my address and came up with this. Okay, so let me kind of extend the trick a little bit. Yeah, that's very cool. So let's just say I say hello, right? And I sign that.
Uh-huh.
So I'm going to sign hello with this account, this kind of yellow blocky here. Now let me grab that signature. We're going to do a little trick here, and we're going to switch accounts to. So say I send this to you, right? This is your account now. You're going to pay the gas. You're going to make this transaction. Okay, so same string. We need to remember to have the string exactly the same. But then instead of signing this with your name, I'm going to just paste that signature in. So now you could send this to the contract, given a signature that I sent you. You can send this to the blockchain, and that message isn't going to be signed by you. It's going to be signed by me.
Right.
There we go. See that? Like that's my signature there. Whoops. Instead, if I were to say hello and sign it with my own account, I don't even know if that signature changed. I bet it did. Well, we'll find out in a second. And
it looks like the same account.
There it is. Okay, there it is. The third one came in. So yeah. So the trick here is that this one was actually sent from one. I need to quit clicking on it. Sent from one account, but was signed by another account, and that's sort of the really interesting thing. So with my bouncer proxy and with MetaTX, I really explore this concept with meta transactions. Let me just take a peek at that contract also. So it
sounds like, it's the big value here is being able to sign transactions on behalf of another.
Yeah, or to verify that you're signing something and then someone else can be doing the work, or like a state channel where so like let's say I had an app right now and you were sitting here watching this go through and you wanted to send me a tip for doing something cool. Like you could just sign the fact that you sent a tip and send it to me, and then eventually I could submit it to get that tip, right? So it's sort of like the state channel thing where you and I can kind of interact, and you can keep on. So say we had not just say we had like a timing thing built into this where you sent 10 tokens and those tokens expired in an hour. But anytime within that hour, you could tip me 2 tokens and then maybe 3 tokens and then maybe 4 tokens, and none of those would submit to chain until like maybe the 5th token came in. I could take that last transaction that says you've tipped me a total of 5 tokens and you've signed it, and then I could submit it on chain. So there's a ton of possibilities that all happen just because of that simple recovery.
Yeah, very cool.
Same thing here. So this is a complex version of what we just built. But basically, there's a signature, a signer, a destination of value, data, reward tokens, and this is kind of laying the groundwork for meta transactions. So this is a whole transaction that I packaged together and sent to an off-chain entity, and that off-chain entity passes it in. and it's validated, and then that transaction is actually executed, right? It actually calls whatever I told it to. So in this case, you've signed something, you've signed a transaction, and you've sent it to someone else, and they put it on chain. So you didn't have to pay any gas, but that transaction went through. So it's like you're able to, in an etherless way, interact with contracts, and this is an identity contract, so you're interacting like through this contract.
Right.
I think that's basically it.
Now, would that open, would that open up the doors for basically like a Dapp to pay your gas fees?
Exactly. Yeah, for sure. So like one of the reasons why I got into looking at building this bouncer proxy was on, I think Kevin from Gitcoin posted up that he was like, there is a huge barrier to entry to get into, it's probably one of these. I can probably just grab it. Let's see right here. This Twitter comment right here. He's basically saying like it costs, yeah, there we go. There's a huge difference in paying nothing and paying 0.001 ETH. Even though that's not very much ETH, it's a huge UX barrier, right?
Right.
So he was asking like, are there dApps that pay? And you can't do like a contract pays. I'm going to stop the share. Is that okay? We should kick back to,
yeah.
There we go. So yeah, so it like stops the UI stops a user dead in their tracks when they have to go to Coinbase, put in some money, wait a couple days, send it to a MetaMask, download MetaMask, inject MetaMask, like all that work just to be able to interact with the dApp. If you just generated an account for them right on the website, let them start interacting with your dApp right away, and they would be interacting in that signature way. They would say, well, I want to do this action on the dApp, and I'm going to sign the fact that I want to do that action and send it somewhere else. And then once that makes it to your contract, you can prove with this EC recovery, with crazy maths that I can't totally explain,
right,
that person is the person that did the transaction. And that, I think that's super powerful for a lot of things, especially since it's so expensive to do stuff on chain sometimes, that we can do a lot of these things off chain just by using the power of public-private key pairs.
Yeah, very cool. Awesome. Well, awesome. That has been quite an explanation and quite a demonstration. I've done a great job, man. I really enjoyed that. Really have enjoyed having you back on the channel today. Is there, before we kind of start wrapping up here, is there anything else that you want people watching to know?
Just for the dApp developers, man, let's do a good job of lowering that barrier to entry, right? Let's make it easy for users. Like the analogy I always give is like, if you post something to Twitter and someone clicks into your dApp, they should be able to immediately start providing value for that dApp. They need to, if you're a social network, let them post content, let them vote on content. And then once they've provided value for your ecosystem and you send them a token, and then that ephemeral account that they have has value, now you've incentivized them to go ahead and, do the rest of the stuff and get MetaMask installed, or Trust or Toshi or whatever you've got for your wallet, and actually like get into the space. I think it'll really drive adoption if we as dApp developers do a good job of lowering that barrier.
Yeah, I think that's great advice, and I think this is a cool way to start doing something like that.
For sure.
So yeah, man, thanks so much for that demonstration. So yeah, guys, we're going to put a link down in the description below for the code from this episode. And also, Austin, where can people find more about your projects and about you if they want to?
AustinGriffith.com. AustinGriffith.com.
Yeah. You're on Twitter, like Medium.
Twitter. Yep, Austin Griffith. I bet if you just Google Austin Griffith, you'll find me. Maybe Ethereum Austin Griffith. I don't know.
Awesome.
But definitely, I've got a ton of different demos in the space and lots of little projects, and I love it, man. I love the build ecosystem. Yeah, very cool. We're excited to have somebody like you doing that, and I'm excited to have you back on the channel today. You keep kicking butt and making videos too, man.
Yeah, it's still doing it one day at a time. Very cool. Well, everybody go check out Austin's work. Check out the links down in the description below. Again, great to have you on the channel. And until next time, thanks for watching Dapp University.